Hello friends, सबको नमस्ते. So today in this video we will create a classification model or you can say develop a classification model using a YOLO. The model will be classify rock, paper and scissor hand gesture. Okay. So I already uploaded my dataset in my Google Drive. I just copy this share link and capped this part. Okay. Just copy this part and paste it here. You will get the link part, then just run this cell. Your data set will get your zip file will get downloaded. It's taking time. I think it's a connection problem. Yes, downloaded. Okay, now we have to unzip it. Make sure the name will be same. This is, let me show you a data set. So this is a data set which contains three folders: train, test and valid. And let me show you the train folder which contain rock, paper and scissor. Paper images like this, and rock images like this, and this way this is a data set. Now let me explain you the code. Ultralytics is a package through which we can import the YOLO model. So here we import the YOLO model from Ultralytics. Then we have to upload the pre-trained model. The model which we are using is YOLOv8L, and you can see that there are multiple model of YOLOv8 like N, S, M, L, and X for the classification purpose. The model which we are using is YOLOv8L, and the parameters, number of parameters it's have is 37.5 million parameters, and the image size on which this model is trained is 224. Okay, and after loading this pre-trained models, we have to train it on a custom dataset. For that, just give your dataset a folder name, and then the epoch will be 20. But right now I just used two, or you can say 3 epoch, because I already have a model which is trained on 50 epoch. Okay, I will upload that model and show you the result of that model. Image size will be 224. Batch is 8, means the model during training not model by the number of images, or make the during training make the batches. I want 8 images should be there in one batch, and this name is like that. When you run this cell, run folder will be get developed, or you can say created. Inside the run folder, classify folder will be there. Inside the classify folder, one folder will be there whose name is decided by us, and this is the name of that. And inside this folder, a wait file will be there. Wait folder will be there, and inside the wait folder, wait files are there. Save true. Yes, we want to save the model. Save period -1 means we do not want to save every epoch wait file. We just want to save the epoch wait file which have a highest accuracy, or you can say minimum loss. Patience 20 is here is meaning early stopping, means after every 20 epoch it will see that there is any improvement in the accuracy or in a loss. If it is not there, it will stop the training, and best model will get saved. Validation true. Yes, we have a validation folder. Yes, we have to validate model. Otherwise, if you do not have a validation folder, then also you can use valid equal to true. It will divide the training images into 80 and 18 to 20% ratio. Let me run this cell. You can see the run folder is get created. So training gets started. Now this is a model. You can see now we have to upload the model which is already trained on a custom data set. I already told you that inside the run folder, classify folder will be there. Inside the classify folder, the folder name which I have decided. Inside that wait folder will be there. Inside the wait folder, wait file will be there. So this is a best.pt is a wait file. This way we load the model, pre-trained model which is trained on custom data set. Now this is a test directory, and we do not have a dataset folder, so it should be removed. Now here we are make the list of all the folder name present in that particular folder like this. You can see a test folder containing 3 folders: paper, rock and scissor. That's why I have to make the list of all the folder name present in that particular folder. Now I have to upload 16 images. For that I have to use 4 rows and 4 columns this way. And for the plotation I have used plot.subplots, and the figure size will be 16 by 16. Here axis is basically used for the iteration over the subplots. For the protection of the 16 images, I have to use for loop for the 16 times. So that's why range is equal to 16. Now I have to first randomly select the folder name. Then after selecting the randomly selected folder name, I have to make the list of all the images present in that particular folder. For that, I have to use OS list directory. Then the path. I have to give the directory. For that, I have to use os.path join the test image folders and the image folder, the folder name which we have decided randomly. This way we make the list of all the folder name, or not folder name, images name present in a particular folder. Now after that we have to make the image path. For that we have to just give the test image folder, then a folder name which we have selected randomly, then a randomly choose the image file, image from the image file list. We have to select the image file name randomly. Now this way we read the image. Now here you have seen that I have passed the image path, not the image. But if you pass the image after reading it with CB2 or the pillow, it does not affect it. It does not affect that anything. It doesn't show any error. It's up to you whether you pass the image path or image directly. And here 0 means because you know that I am passing only the one image. So to get the result or prediction of that particular image, I have to use 0 index value for that. So that's why I have used 0 here. Now uh, for your better explanation what is happening here, what is result dot props and all that thing, let me print them. First I have to print result, then print result dot props. Okay, then the print model dot names. What is happening here, let me explain you this whole thing. Okay, and break. Just for the one iteration I will give you all the information. Let me first see that yes, training is completed. And one more thing, that here GPU mam is GPU memory which is required during training of that particular epoch. Loss is a classification loss. Here 315 is basically the batch size which is used here, and 24 is in validation which is used here for. Okay, so now let me run this for better explanation that what is happening here. You can see that first I have printed the result, then the result.prop, then the model name. So this is a result, and you can see that all the details present, all the detail or classification or the prediction is basically you can say stored in this prop attribute. And when I will print result.prop, this is a scenario, or you can say this part is here. Result.prop is till here, and you can see we have a three classes. So that's why it's have a tensor, or you can say list of three probabilities. Zero for you can so zero for the you can say zero for the paper. See model dot names dot model dot name give me this thing, which class id belong to which class name. So here's zero index value, you can say zero index value belong to paper, one index value for the rock, and two index value for scissor. And these values are basically describing the probabilities that particular image belong to which particular class name. Okay, and you can see this top one. Here I've used uh, result.prop top one and result.prop top one conf dot item. What does this mean? Let me explain you. This result.prop top one give me the class id which have a highest probability. So zero this one, and result.top one confidence give me the probability of that particular class id. So it's act as a confidence. So this way we print the, or you can say retrieve the information from the result or the prediction. Now I already explained you, after getting the class id we have to use a class id for the class name, and this is a confidence. And after, you can see I have read the image in cb2 format, so I have to convert that image into rgb because cb2 read the image into bgr format. Now I am so image, then the class name and confidence. So this way we print the result, or we can see the predictions. So let me check how many predictions are wrong. Rock, paper, scissor, 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 paper, rock, scissor, 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 rock, paper, rock, scissor, rock. all the predictions are correct. It means the model which is trained on 3 epoch is also showing the better result. But I have a model which is trained on 50 epoch, but the result is it is pretty good, or it means a higher percent accuracy is there. So it's not required to show the result of the model which is trained on 50 epoch. It is the model which is trained on 3 epoch is also showing the result code. So this is up. You can download this model and you can use anywhere you want to it, whether in your games, rock paper scissors game, or any web, or you can say a mobile app. Anywhere you can use it. So this is the explanation. I have explained each and everything line by line. So please like, share, and subscribe. Thanks to all.